Alright, we're going to start on number 1 by listing all the possible rational roots. So we're going to list the factors of 6, which is 1, 2, 3, and 6. Divide that by all the factors of 3, 1 and 3. So if we're going to make a master list, we're going to have 1, 2, 3, 6, then 1/3, 2/3, 3/3 is the same as 1, and 6/3 is the same as 2. So we're just going to tack on 1/3 and 2/3 here. They want you now to find any actual rational roots to that. So let's graph it first. So it looks like there's one root here. So let's find out what that root is. So left bound, right bound, and then enter. So the 0 is roughly 0.596. None of these values here are 0.596, which means that 0.596 is irrational. So there's no rational roots for this problem. We're going to do the same thing here. So list all the factors of 10, 1, 2, 5, and 10. And divide that by the list of factors of 10, 1, 2, 5, and 10. So all the possibilities are going to be 1, 2, 5, 10. 2 over 1 is the same as 2. 2 over 2 is the same as 1. 2 over 5. 2 over 10 is 1/5, so we'll include that. 5 halves. 5/5 is 1. 5/10 is 1/2. Oh, we also have 1/5. Oh, we already have 1/5 here. 1/10. Should be it. So let's see. 1/2, 1/5, 1/10, 2/5, 5 halves, 5/10 is 1/2, 10 halves is 5, 10/5 is 2, 10/10 is 1. So this is the list of all possible rational roots. Now let's take a look at the graph and see if any of those are in fact roots of the function. So 10x cubed minus 7x squared plus x minus 10. So it looks like right over here is our only 0. That's real. So let's do a second trace just to see where that is. So left bound, right bound, and then enter. 1.255. That would be none of these. So it has no rational roots. Alright, number 3, they just want you to write down another 2 roots. So the conjugate root theorem tells you that I will also be paired with negative I, and 7 plus 8i is going to be paired with 7 minus 8i. Those are your other 2 roots of the function. Number 4, they want you to go a step further. They not only want you... Okay, just got disrupted here by some students thinking that they had study hall with me, but they didn't. Where was I? Alright, number 4. So they want you to write a polynomial function. So it's a function building kind of problem. In addition to 3i plus 9, we're going to have negative 3i plus 9. Now you might be wondering why I didn't make it 3i minus 9. Well, the proper way to write this really is supposed to be a plus bi, meaning that the real root should be here and the imaginary root should be written after it. So another way to write this is 9 plus 3i. So the conjugate to that would be 9 minus 3i, which is the same thing as this. So you could write it as 9 plus 3i and 9 minus 3i, which is exactly what this pair is. So what we want to do is we want to take this pair and build a quadratic from it. So it's going to be x squared, and then we want to add these two together. When I add them together, the 3i and negative 3i cancel, the 9 and 9 add to an 18. So it's going to be the opposite of that sum, x. And we want to multiply. So 9 plus 3i times 9 minus 3i. You only want to do f and l in FOIL since they're conjugates. So 9 and 9 would give me 81. Positive and negative 3i would be negative 9i squared, which makes this positive 9. So you just get plus 90. And that's your function. Number 5, Descartes' rule of signs. So we're going to do a sign chart for p of x and for p of negative x. The signs for p of x is positive, positive, negative, positive. For the p of negative x, I'm going to change the odd powers. So this term and this term. So this is now going to be negative. That stays the same because it's an even power. That changes to a positive, and then you've got that positive. So we count the number of sign changes. That's the same. We have a change here and a change here. So that means you're going to have 2 or 0 positive real roots. Over here we have 1 sign change, so 1 negative real root. Number 6, they want you to find all of the rational roots. So let's get the calculator out and take a look at the graph. So 6x to the 4th minus 7x squared minus 3. Alright, so it looks like we have a root here and here. So what we can do is we can check to see if those are rational or not. So let's do a second trace 2. Okay, left bound, right bound, enter. Negative 1.224745, that's not rational. And this is going to be positive 1.224745. We can do that. Second trace 2. Left bound, right bound, enter. So 1.2247449. So none of those are rational, so there's no rational roots for this problem. Number 7, division problem, long division. So x minus 3 is the divisor. X cubed minus 2x squared minus 5x plus 6 is the dividend. So x cubed divided by x is x squared. We're going to multiply this through now. X squared times negative 3 is negative 3x squared. Change the signs, add down. X squared divided by x is x. We multiply through. X times negative 3 is negative 3x. Change the signs, add down. Negative 2x divided by x is negative 2. And we'll multiply through. Negative 2 times negative 3 is positive 6. Change the signs, add down. You get 0 for a remainder. So there's your answer. Number 8, synthetic division. So because we're dividing by an x plus 2, we want to synthetically divide by -2. We want to include all of the exponents. So 7 has a coefficient of 1. X to the 6th has 0. X to the 5th, 1. X to the 4th, x cubed, x squared, x, and then the constant. So we're going to bring the 1 down, multiply, add down, multiply, add down, multiply, add down, and then you keep going through. Okay, so there's your remainder, your constant, your x, x squared, x cubed, x to the 4th, x to the 5th, x to the 6th. So your answer, x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40 with a remainder of -68. Number 9, describe the shape by determining end behavior. So we'll do end behavior and the number of turning points. So it's an odd function and it's negative. That means from left to right it's going to go downhill like this. So we have to split up our limit notation. So the limit as x approaches -infinity of the function is positive infinity, because as we go left it increases. Now as I'm using f of x function notation here, but this can be written as f of x. Also the limit as x approaches positive infinity of the function is -infinity, because as I go right, as I increase in x values, my y values decrease. Turning points, we're going to have to take a look at the graph. So -2x cubed. Alright, so it doesn't really look like this. I mean, it does in a sense, in the fact that it goes downhill, but there's no like bottoming out and then topping off. Like there's no humps. It just goes down. I mean, it does curve and bend a little bit, but it's always going downhill. So there's no turning points. Alright, a friend asks you to explain the rational root theorem. How would you explain it? Well, again, the rational root theorem basically states that if you have a polynomial function, you're going to end up having a constant value, which is going to be representative of Q. Sorry, P. Should be a P here. And then you are going to also have a leading coefficient of the first term. Let's just say it's x to whatever power, x to an n power. What the rational root theorem states is that if you list all of the possible factors of P and divide them by all the possible factors of Q, and you write out a list of all the combinations of that quotient of factors, then you will have a master list of all the possible rational roots for that function. And that's pretty much it.